Okay, friends, welcome to session 3 of private 5G networks design, planning, and optimization. So, I hope you all are happy, healthy, and doing well. So, this is the agenda. So, we have already covered 5G building blocks for private networks, and we have already covered mastering the basics of private networks. And after that, we have also gone through private network architecture and components. So rest of the topics like CBRS for private networks, private network enables, we will try to cover it today. Okay, so we'll try to cover as much as possible today, and rest we'll cover in the next session. Before jumping to the next session, I just want to tell you that please remember the specification which are used in case of private networking. So for private networking, we are using this specification TS 23.501 and TS 23.502. There may be many more specifications, but most basically we use these two specifications. So 501 is basically related to private network architecture, and 502 is related to procedures. Okay. So hi friends. Again, this is Gaurav Goyal, and thank you so much for joining the today's training session. And I really appreciate your time, and I hope you find the session useful and informative. And before we start, let me quickly introduce myself. My name is Gaurav Goyal, and I have around 20 years of experience in the telecom industry. And over the years, I have worked with major telecom operators like AT&T, T-Mobile, Verizon, Dish, etc. And I also worked with companies like Ericsson, Samsung, and Nokia in the past, and also with Infovista as a product manager for their tool called Planet. I started my telecom journey with 2G, then worked on 3G, 4G, LTE, and 5G. And today I'm continuing to learn and work in areas such as like 5G, AI, NTN, Python, private networks, and IBS and DAS. And I also preparing for PMP certification to improve my project management knowledge and skills. So if you like to learn more about my experience and background, you can view my LinkedIn profile. So I have already shared the link of my LinkedIn profile. So you can go and see the LinkedIn profile as well. So if you go to my LinkedIn profile, you can see all kinds of my certifications I have done, all the posts you can see, right? In addition to that, all the recommendation I have received in the past from my previous managers and my previous students as well. So I've already shared the link, so you can go through that link. And I would like to share one of my favorite quotes by Albert Einstein. The only source of knowledge is experience. So I believe books and trainings gives us knowledge, but real understanding comes from applying it in real projects. So these ID cards are more than company badges. So they represent my journey from 2G to 5G and now private 5G, NTN, AI, and 6G as well. So every project has taught me some valuable lessons. So today I will be sharing not just theory, but practical experience from my re- real world telecom deployments. So like in every webinar, let's quickly go through a few codes which I like and which I want to share with you. So friends, I want to share one simple message with you. Don't give up. You may be much closer to success than you think. Sometimes we work hard and do not see the results, but that doesn't mean we are not making progress. Keep learning, keep practicing, and stay focused. Be patient. Every small step you take brings you closer to your goal. Remember, success often comes to those who never quit. So keep going. Your breakthrough could be just one step away. So many people do not achieve their goals because they have fixed mindset. So person with a fixed mindset says, I already know this. I'm not good at this. This is enough. I don't want to make mistakes. And because of this, they stop learning and stop growing. But successful people have growth mindset. They believe I can learn. I can improve with practice. Mistakes help me learn. Feedbacks help me become better. I will stop making excuses. I will never stop learning. I will never give up. So that's why all of us are here today. You joined this webinar because you want to learn something new and improve your skills. So whether you are a student, a beginner, or an experienced engineer. Always keep a growth mindset. Remember, the day you stop learning is the day you stop growing. Friends, I would like to share one more important lesson. The first step to learning is realizing that we don't know everything. If we think I already know everything, our mind closes and we stop learning. But when we say, I don't know, let me learn, we open the doors to the new ideas, new skills, and new opportunities. Think of it like this: if your cup is already full, you can't pour anything into it. But if your cup is empty, you can fill it with new knowledge. That's why I encourage everyone to come to every webinar with an open mind. You don't have to know everything today. As Martin Luther King said, you don't have to see the whole staircase. Just take the first step. And I would like to add one more thing of my own. The first step towards knowing is to realize that you do not know. So keep an open mind, take the first step, and let's start learning together. And I request everyone, please mute your audio connections and please place phones on your silent mode. And please don't do any kind of multitasking. As I said at many times that there is no thing called multitasking. Even a genius can't do two tasks at the same time. He just switch task from one task to other, right? And multitasking reduce our efficiency. So I request everyone, please don't do any kind of multitasking. So in the last two sessions, we have already covered the 5G building blocks, 5G motivation, all these things we have covered in our previous two sessions, right? NGMN vision, what are the 8 use cases, fourth revolution, 5G key drivers, 5G use cases. Then we have some quizzes also. Then we have seen the 5G usage scenario also. In addition to that, we have seen 5G performance requirement in the terms of KPIs, in terms of capabilities, in terms of peak data rate, area traffic capacity, all these things we have already covered in our previous sessions. At all the latencies, everything we have already covered. So this is the 8 currencies which is very popular in case of 5G. That also we have covered. In addition to that, we have taken lots of quiz as well. And after that, we have checked the numerology as well. So you know that in case of 5G, numerology is very flexible. In case of LTE, our subcarrier spacing is fixed, which is 15 kilohertz. But here it can be 15, 30, 60, 120, 240, and so on. This cyclic prefix also we have covered in detail. So OFDM symbols, OFDMA, subcarrier spacing, TTI, all these things I have covered, right? So after that, we have also started the basics concepts of private network. So we have seen that private network is not a new concept. We have seen that it is already launched many years back in terms of PBX, right? Private branch exchange. And we have seen the example of hotels, right? Where people talk to each other without connecting to the external network. And we have seen that private networks is also widely used in case of like Tetra for the emergency operations, for polices, for public operations, all these things. P25 is also P25 for the emergency in case of US, right? And then GSM, we have seen that that is the private networking case for GSM railways. Then LTER is the private networking case for LTE railways, right? We have discussed that in detail. After that, we have seen that why so much hype about the 5G private networking, and we have seen the all the use cases in case of enhanced mobile broadband, MMTC, and UR LLC as well. After that, we have seen that how a private network can be implemented. So we have seen the different architectures. So in one of the architecture, we can see that it's standalone private architecture. So in case of that, G Node B and EPC are both controlled by the enterprise, or you can say that they are both located inside the enterprise. In case of second type of architecture, core is unique to enterprise and core is unique to public, but the RAN, right, like BTS, towers, antennas, that is shared between enterprise and public. Right? So this is also second type of architecture. And third type of architecture also we have discussed that with the help of network slicing. So here the RAN part is unique to enterprise, but core is shared between public and private, but it is not shared Absolutely. So here, core is divided into something called logical slices, or you can say logical network, and that is called slice. So one slice is completely dedicated to the private network, right? And that slice can't be used for the public. So that is also one of the way to implement the private networking. And we have seen all the differences. What are the characteristics of the private networking? That also we have seen. And what are the main benefits? And we have seen the CBRS as well, which is band 48, right? And it operates between frequency 3.55 to 3.7 gigahertz, right? And in addition to that, we have seen the various CBRS uses also, and what is the history of CBRS. And then CBRS tier architecture also, we have seen that it is divided into three parts. One is incumbent, one is priority access license, and one is general authorized access, right? We have seen all the differences between that. The incumbents will be get the most priority, right? So it has full band between 3.55 gigahertz to 3.7 gigahertz. And but depending on the use case, like for US military radar, it gets the complete band from 3.55 to 3.7. But for fixed satellite operation, it can be between 3.6 gigahertz to 3.7 gigahertz. And for wireless ISP, it may be between 3.65 gigahertz to 3.7 gigahertz. But this incumbent users always override PAL and GA, which we have discussed in the next slides. So, so PAL is the paid version of the CBRS, right? So here, maximum 10 megahertz channel can be guaranteed, and maximum 7 PALs can be assigned per geographical parcel. So maximum 70 PALs can be assigned in a per geographical 70 megahertz can be assigned in a per geographical areas. And it is not assigned like full band. So it is assigned between 3.5 gigahertz to 3.65 gigahertz. And after that, we have seen that GAA. So GAA is general authorized access. So when incumbent and PAL users are not in use, then GAA can access the CBRS spectrum. So these are the three tier structure we have already discussed in our previous classes so far, right? Friends, any questions so far? And then we'll jump to the new topic, which is spectrum sharing ecosystem. If no question, can you write no in the chat box, please? Okay, thank you. Okay, so can you please write no in the chat box if you don't have any questions? Okay, thank you. Thank you for all the answers. Okay, so the next topic we have to discuss is, or the new topic for today is spectrum sharing ecosystem. So here we will discuss what are the various devices or systems required for the CBRS bands. So you can see here we have few key components required for CBRS. One is CBSD, which is Citizen Broadband Service Device. As I said earlier that instead of giving the entire spectrum to one operator, the CBRS band allows different users to share it in organized and a controlled way. So to make that possible, several components work together. For example, first one is Citizen Broadband Service Device. So these are the CBRS radios, band 48 radios, right? That provide wireless coverage. Then we have this domain proxies. So it acts as a middleman. So if we have CBSD, CBSD is connected to the domain proxies, and domain proxy is connected to the SAS. We'll discuss SAS here in next few moments. So CBS is connected to the domain proxies, and domain proxies is connected to the spectrum access system. So domain proxies acts as a middleman. So instead of every CBSD taking directly to SAS, the domain proxy manages communication for many devices. So CBSD doesn't have to talk to SAS directly. Then we have EMS, which is used to monitor, configure, and manage the CBSD. Then you have EUD, which is like our cell phone devices. But in, addi- in addition to cell phone devices, in case of private networking, we have to connect smartphones, laptops, cameras, IoT devices, robots, manufacturing devices, all these things we have to connect. And then we have this FCC database and the ESC. So ESC is environmental sensing capability. So it monitors for the military radar. So if radar is detected, it immediately informs the SAS, and SAS can tell PAL or GA to free some resources for radar because radar is having highest priority. Right? Then we have this FCC database. So it provides information about the licensed users and the protected areas. And the last but not the least is the SAS. SAS, you can say, is the brain of private networking. It's very important component. It's a brain of private network. So it decides who can use which frequency and when they can use. So if you look at the diagram, you can see that SAS is at the center of ecosystem. So it communicates with the FCC database, ESC, domain proxy, and the CBSDs to ensure that everyone shares the spectrum fairly and without causing harmful interference. Then we have this CBRS, frequency management terms. So you can see that we can go here in more details at the three components that makes CBRS spectrum sharing possible. So first one is SAS, which is Spectrum Access System. As I said that it is the brain of CBRS network. So what's its job? So its job is to keep track of who is using the spectrum. It assigns available frequencies to all the CBSDs. So when I say the CBSDs, just visualize them as a radios, small radios, right? So CBS is Citizen Broadband Service Devices. So SAS provides available frequencies to CBSDs. It prevents interference between different users. It protects higher priority users such as military, right? So think of SAS as a traffic police officer. So traffic police officer, when the road is busy, so it can pass just the VIP traffic and it stops rest of the traffic, right? So it decides who can go, when they can go, and at which time, and on which lane they can go. Then we have this ESC, which is environmental sensing capability. So it is like eyes and ears of CBSD system. So it acts as eyes and ears for the CBRS system. So its job is to detect when US Navy radar or other protected federal users are using the CBRS band. So if radar is detected, the ESC immediately informs the SAS. SAS tells nearby CBSDs to change the frequency or stop transmitting at all if nothing is free. So this protects the military from interference. So think of ESC as a security guard watching for the affected users. Then the last important part is domain proxy, right? Domain proxy. So it acts as a middleman between many CBSDs and the SAS. So CBSDs doesn't have to directly connect with SAS. It has to connect through domain proxy. So instead of every CBSD communicating with the SAS individually, the domain proxies collect the requests from the many CBSDs and sends them together. It requests channel from SAS, receives channel assignments, it distributes those channels to CBSDs and reports back to the SAS. So think of it like a class monitor. So instead of 50 students asking a teacher one by one, the teacher collects all the information from the monitor and monitor collects everyone request. So simple summary is that SAS is like the brain of CBRS system, ESC is like the eyes and ears, and domain proxy acts like a middleman between SAS and ESC. Right? So together, these three components ensure that CBRS spectrum is shared fairly, efficiently, and without any kind of interference. Then we have this CBSD, Citizen Broadband Service Device. So CBSD or Citizen Broadband Service Device is simply the radio. As I said earlier, it is simply the radio or base station that provides wireless coverage in private LTE or private 5G network. So think of it like a small cell that connects user device such as smartphones, laptops, tablets, scanners, robots, manufacturing machines, all these things can be connected to CBSDs. But every CBSD must register with SAS. So if CBSD is not registered with SAS, it will not work. And CBSDs are divided in two parts. One is category A CBSD and one is category B CBSD. So category A devices are commonly used for indoor enterprise networks such as offices, hospitals, warehouses, factories, shopping malls, campuses, and they can be installed indoor or outdoors. And maximum transmit power is 30 dBm EIRP. And what is HAAT? HAAT? Anyone? What is HAAT? Yes. The right answer is height above average terrain. So HAT in case of category A CBSDs is maximum 6 meter or less. Then we have this category B CBSD. So they are used for large outdoor coverage, and they are commonly deployed like in large campuses, industrial sites, mining operations, oil and gas facilities, utility networks, all these things. And outdoor use only, and they can transmit power up to 47 dBm. So whenever you're designing a private 5G network, choosing a correct CBSD depends on whether you are using indoor or whether you are using outdoor. So how much is the coverage area? How much is the deployment location distance? And what are the power requirements? So based on that, you will choose which CBSD to use, category A CBSD or category B CBSD. And during CBSD, we have to take extra requirements and extra installation precautions because it can affect our private networking. So what are those requirements? So first one is communication requirements. So first thing is CBSD must be able to communicate with the spectrum access system. The SAS may send instructions such as change your frequency. It may say that reduce your transmit power. It may say that stop transmitting at all, right? So the CBSD must follow the instructions within the 5 minutes. This ensures the spectrum is shared safely and without causing any interference. Then we have this location requirement. The SAS always needs to know where the CBSD is. If the CBSD is moved to a new location, it must report the SAS within 60 seconds. This is important because spectrum availability depends on the location. Then we have this installation guidelines. So category A CBSD can be installed without the help of CPI, certified professional installer. But for category B, it must be installed and certified by CPI, right? Certified professional installer. It can't be operated until the CPI verifies and register the installation. So why CPI is required? Just to check the correct location, height is correct, antenna direction is correct, the power follows the FCC rules. That's why category B is very important. Category A is small, height is not that much, so it is easy. But category B should be installed with the help of a professional CPI, certified professional installer. So what's the summary of this slide? You can say that CBSDs always stay connected to the SAS. They report any location changes to SAS. They follow SAS instruction within 5 minutes, right? So these requirements help ensure that CBRS users can safely share the spectrum without causing harmful interference. Then we have this EUD, and user devices. So an EUD is simply a device that people use to connect to the private LTE or private 5G network. So EUD is cell phone, like cell phone we are using, that is also called EUD. But the thing is that if you are not employee of that particular enterprise, you can't use their network, right? So you have to put their SIM card in your cell phone to talk to each other or to make cell phone working. And examples can be smartphones, laptops, tablets, desktop computers, industrial handheld terminals, IoT devices, sensors, cameras, robots, all these kind of things. These devices do not communicate directly with SAS. As I told earlier, they communicate with CBSD. So CBSD communicates, first of all, EUD communicates with CBSD and CBSD communicate with the SAS, getting permission to use the spectrum, and then provides the wireless services to end user devices. So again, how the communication flows: EUD communicates with CBRS, or you can say CBSDs, Citizen Broadband Service Device, and then CBSD communicates with SAS. And if something is available, SAS will provide that thing. Again, EOD do not need to register with SAS. Only the CBSD communicates with the SAS and manages the spectrum. So simple example can be workers use smartphones and tablets, robots and sensors and data, security cameras, AGVs, right? Automated guided vehicles, right? So all these can be considered as EUDs. So all of these are end user devices. So they connect to the nearest CBSD, and CBSD take care of communicating with SAS. Or you can say that the CBSD gets spectrum authorization from SAS while the EOD attaches to the CBSD through 5G or LTE procedures. Then we have this CBRS antennas. So just like any wireless network, antennas are used to transmit and receive radio signals between the CBSD and the end user devices. So CBSD operates in, you know, that 3.55 to 3.7 gigahertz band 48. So there are different kinds of CBS antennas depending on the application. For example, one is omnidirectional antennas. So it is commonly used in offices, warehouses, indoor private 5G networks where coverage is needed all around the antenna. Then we have this directional antennas. So a directional antennas focus the signal in one specific direction, and it provides long coverage distance, better signal strength, and less interference as compared to omnidirectional antennas. And they are very used, and these antennas can be used in like outdoor deployments, campus networks, point to point links, point to multi point links. All these things can be used for directional antennas. Then these antennas can have single polarization or the dual polarization. And you know the advantage of dual polarization, that it improves signal quality and network capacity because they can transmit and receive signals in two different polarization. Then we can have single band antenna, multi-band antenna to accommodate different technologies. And then we have MIMO beamforming. So most modern CBRS antennas support MIMO, such as 2 by 2 MIMO, 4 by 4 MIMO, and this improves coverage and reduces interference. And choosing the right antenna is an important part of designing a reliable and high performance network. Now, let's talk about Wi-Fi. So before we compare Wi-Fi with private cellular, let's quickly understand how Wi-Fi works. So Wi-Fi is a wireless networking technologies based on IEEE 802.11 standard. And it has been widely used in homes, offices, schools, coffee shops for many, many years since 1997. So in Wi-Fi, your devices such as smartphones, laptops, and tablets connects to a Wi-Fi access point, or you can say the router. The access point is connected to the internet through a wired connection, and it provides wireless connectivity to the nearby devices. And one of the biggest advantages of Wi-Fi is that it is very easy to install, low cost, and offers high data speeds, making it ideal for homes and small offices. But Wi-Fi has some limitation. That's why 5G 5G is more preferred as compared to Wi-Fi, because Wi-Fi provides short range coverage. So large buildings require many access points. As more users connect, network performance can decrease. User can experience interference from neighboring Wi-Fi networks. Mobility is limited because devices must roam between different access points. In large industrial environments, maintaining seamless connectivity can be challenging. Some example can be, for example, imagine a warehouse. So with Wi-Fi, you may need 20 or 30 access points, right? Cover the entire building. As workers move around, their devices switch from one access point to another, which can sometimes interrupt connectivity. This is one reason why many industries are moving towards private 5G, especially for business critical applications like in manufacturing, Toyota, BMW, Amazon warehouse, all these things, right? So Wi-Fi is affordable and easy to deploy, but it is suited only for homes, offices, and small businesses. But for large areas, high mobility or quick mobility or low latency and mission critical application, private cellular networks are often the best choice. Now let's understand private LTE. So private LTE network is cellular network that is owned and managed by an organization instead of a mobile operator. So unlike public cellular networks, so organization has complete control on the network, on the users, on the data, and on the security as well. And private networks can operate the license spectrum like AT&T has, T-Mobile has, Verizon has, right? Unlicensed, it may be, you talk about, if you know about B46, right? B46 is the unlicensed spectrum and its range is between 5150 megahertz to 5925 megahertz, right? And then shared spectrum, which is CBRS band 48 between 3.5 gigahertz and 3.7 gigahertz, right? So LTE provides better coverage over large areas. It has low latencies, higher capacities, better mobility, and more reliable communication. That's why private LTE is widely used in manufacturing plants, warehouses, airports, ports, mining sites, and all these things, right? But private LTE also has some challenges. It requires LTE infrastructure, spectrum access, SIM management, proper planning and design, and skilled engineers. That's why we are here so that we can learn how to design, optimize the private network. So now let's look at three key characteristics of a private LTE network. So private LTE is designed for maximum uptime. So in industries such as factories, airports, hospitals, ports, the network can't afford downtime because critical operations depend on it. That's why private LTE is built with redundant and resilient network architecture, achieving very high availability. You can see that availability can reach up to 99.999%, right? But in case of 5G, we will discuss later, that is 99.9999. This is called three nines, this is called five nines. So reliability is improving with every technologies. Then we have this security. So since data will not go out of the network. So this network is highly secure because only authorized users and devices can access the network. And private LTE protects data using several security managements like SIM authentication. Then we have this mutual authentication, right? During connection between device and network. Then we have payload, payload encryption, and then we have integrated protection, right? In case of payload, it encrypts the user. So it encrypts the user data while it is being transmitted over the air. So it protects it from eavesdropping or authorization, right? So it protects it from unauthorized access. Then we have this integrated protection. So it ensures that only the transmitted data is not modified. So these features make private LTE much more secure than a typical Wi-Fi network for enterprise and mission critical applications. Then we have this performance. So private LTE is built for high performance applications. So it provides high speed data transmission, low latency, and supports thousands of connected devices. And this make it ideal for many things like HD video surveillance, AGVs, robotics, smart manufacturing, remote monitoring, all these things. Now let's talk about the performance of a private LTE network with an example. So the actual speed depends on various factors. You know it. It may depends on the bandwidth. It may depends on the number of users. It may depends on signal quality, and it may depends on the network congestion and also on the carrier aggregation. So these are the few points where LTE speed is dependent. So you can see here that the download speed can reach around 130 to 188 Mbps, depending on the LTE TDD configuration. Similarly, the upload speed can be reached around 27 to 54 Mbps depending on the network configuration. Let's see some of the use cases for LTE. So the first use case is smart factories and industry 4.0. So private LTE connects industrial robots, AGVs, sensors, cameras, and pick up and place machines. Then we have mission mission critical services. So this includes police, fire departments, emergency response time, power plants, electrical utility components, military and government organization, all these things. So these organizations needs a network that is always highly secure, available, reliable, and extremely low latency. Another important examples can be mining, oil and gas, agriculture, utilities, all these kinds of things, right? So these sites are often located in remote areas where public cellular coverage is very weak or unavailable. So private LTE ensures connectivity for workers, drones, autonomous vehicles, all these things. The fourth point is venue services. So it is widely used in public venues like airports, stadiums, hospitals, sports, university campuses. So these locations have thousands of users, including employees, contractors, visitors, and the emergency responders. So private network can provide secure, reliable, and high capacity connectivity for all of them. So other examples of private LTE use cases can be Internet of Things or smart cities. It can be used in utilities, transportation, and healthcare as well, because doctors can access data quickly. It supports patient monitoring, telemedicines, medical devices, all kinds of things like connected ambulances, ICU monitoring, medical imaging. So these examples show that private LT is not just for factories. It is also widely used in smart cities, transportations, utilities, healthcare, all these things. Let's see the comparison between private cellular and Wi-Fi side by side. So first one is ownership. So it is owned and managed by the organization, and here managed by the organization IT teams. Then coverage large areas with fewer base station, but here small area. Mobility, external mobility with seamless handover. So you can know that for LTE speed is 350 kilometers per hour. So at this speed, mobility is a no problem. Then we have security, very secure SIM cards based on authentication. Good security is possible, but it depends on proper configuration. Then reliability we have discussed. Capacity, capacity supports thousands of connected devices. But in case of Wi-Fi, capacity is very much limited. Latency, one of the most important factor in case of private network for factories, is very less in 4G. Then we have few examples where we can use Wi-Fi or where we can use LTE CBSDs, right? It can be factories, warehouse, ports, airports, miners, hospitals, and the utilities. So we have covered 4G. So we have already covered Wi-Fi. We have already covered LTE or 4G. Now our duty is that we should cover the 5G as well. So let's understand what makes private 5G so useful, and people are moving from private LTE to private 5G. So first thing is higher bandwidth. So private 5G provides much faster data rates. It can transfer large files high definition videos, and sensor data quickly. So example, a factory can stream videos from hundreds of cameras at the same time. Then we have this lower latency. So we know that how important is latency KPIs. So private 5G has a very low delay. So devices respond almost instantly. A robot can stop immediately if it detects an obstacle, right? So we can use that example. Then we have this improved mobility. So devices stay connected while moving. The network supports seamless handovers without losing connections. So AGVs, forklifts, and drones remain connected as a and they move around a warehouse. Then we have support more devices. Private 5G, you know that it can device support up to 1 million devices, right? And in case of LTE, it can support only 100,000 devices. So LTE is less capable as compared to 5G. Then we have this complete control. The company owns and manages the network. Only authorized users and devices can connect. So you can take example of hospital. A hospital allows only approved doctors and medical equipment to access the network. Then it is highly secure and private. So data stays inside the enterprise. This provides better security and protects sensitive information. So you can say that a bank keep customer data on its own private network instead of sending it to the public network. Then we have this in the ideal for industrial operations. So private 5G is reliable, secure, and designed for mission critical applications. It works well in factories, ports, mines, airports, and the utilities as well. And examples can be smart manufacturing, remote machine control, AMRs, smart warehouse, oil and gas. So to summarize, private 5G offers higher speed, lower latency, better mobility, and it supports thousands of devices. That is why industries around the world are rapidly moving, adopting 5G private network. Then we have this 5G private network enablers. To understand 5G private enablers, first of all, we have to understand main components of 5G. So what are the building blocks in terms of network capabilities in 5G? So first of all, we have extremely large bandwidth. You know that in case of LTE, maximum bandwidth can be 20 megahertz. But in case of 5G, it can go up to 400 megahertz or more as well. Then we have this mixed spectrum. So it supports FR1, which is between 400 megahertz to 7 gigahertz. And then FR2, which is 24.25 gigahertz to 52.6 gigahertz. And then we have mid band that is included in the FR1. So in case of high band millimeter waves, those channel bandwidths are lot larger. So you can see that according to Shannon's law, right? Capacity is equal to bandwidth log 1 plus sin r. So if bandwidth is high, our capacity will be high, right? And the spectrum, as we have already discussed, it can be licensed, like in case of AT&T, T-Mobile, Dish, they are using, and then it can be shared, like CBRS, or it can be unlicensed, like NRU band 46, right? So between 5 gigahertz and right, this way you can utilize these things. So other building block is beamforming or beamforming and MIMO. So beamforming is successful when we have very large number of antenna elements. So as we know in 5G, we can use millimeter spectrum as well. Millimeter waves in very small wavelength, or you can say very high frequency. So you know very well that antenna size is a function of wavelength, right? So at high level, you can say that at 700 megahertz, wavelength is 0.42 meter. At 28 gigahertz, wavelength is 0.01 meter. At 60 gigahertz, you can say that 0.005 meters. So as the wavelength is decreasing, our antenna size is also decreasing. That's why beamforming and MIMO are introduced in 5G as the essential part. In 4G, it is like good to have, but in 5G, it is the essential part. Then we have this flexible frame structure. As I said earlier that in case of LTE, subcarrier spacing is fixed, which is 15 kilohertz. But in case of 5G, it can be 15, 30, 60, 120, and 240. I have seen till 240 only. And you can see that their TTI for 15 kilohertz, TTI can be 1 millisecond. For 30 kilohertz, it can be zero point 0.5 millisecond. For 60, for 60 kilohertz, for 60 kilohertz, it can be 0.25 millisecond, and so on. So you have seen that slot timing is the inverse of sub-carrier spacing. And for more details of 5G frame structure, please see the video in the YouTube, my video. It has detailed more than 1 hour video. It is complete details of 5G frame structure, right? So in case of 5G, slot timings can be high as millisecond or low as quarter millisecond. We thought LTE is fast. In LTE, we make 1,000 decisions per second. But here we can make 8,000 decisions per second in case of 5G. Really fast. So this is how quickly we spend these things over the air. Then we have radio access network. We know that in case of Open RAN, radio access is divided in two parts. One is CU and one is DU. So DU processed real-time radio functions and CU handles high layer protocols and the mobility. Another capability of 5G is support for edge computing and the network slicing. So one of the advantages of edge computing is that we can reduce the overall latency. Earlier, data has to first go to the core before being processed and then delivered to the user. But in case of MEC, data will be processed at G node B rather than taking to the centralized cloud network. So it will save lots of transmission time interval, and it can use the video analytics, AR, VR, robotics. All these things can be used with the help of MEC. Then network slicing. So network slices provide end-to-end logical networks. The logical networks are completely isolated from each other and work independently. So we have seen many cases in 5G like EMBB, URLLC, and MMTC. So if network slicing is not there, we need different infrastructure for each case. Network slicing. So example like you can allot one slice for robots, one slice for security cameras, one slice for office users, right? And after that, we have virtualization in RAN and core. So network functions run as a software instead of dedicated hardware. So we have explained in detail 5G architecture. So please go through that video also. And then we have this AMF, which is access and mobility management function. So it handles and mobility and the registration. So it handles the handovers. Then we have SMF, which is session management function. So it assigns IP addresses. And then we have UPF, user plane function, that carries data. Now let's understand the four main advantages of private 5G: coverage, capacity, performance, and the reliability. So coverage, private 5G can operate on low band, mid band, and millimeter wave spectrum, right? So each frequency serves as a different purpose. So low band, it has longest coverage and it can be used for the rural areas. Then we have mid band, which is around 3.5 gigahertz, and our CBRS also comes in the mid band. So you know that CBRS band 48 is between 3.5 gigahertz to 3.7 gigahertz. Then we have C band, which is between 3.7 and 0.98 gigahertz. Then we have this millimeter waves. It is 24 gigahertz or above. It has very high speed, very high capacity, but short coverage distance. So they can be used in stadiums, airports, convention centers, and we have NRU as well, which is unlicensed band 46 and between 5 gigahertz and 6 gigahertz. Then we have this capacity. So LT uses 20 megahertz, but 5G uses 400 megahertz. So it uses wider channel bandwidth, so it can be higher. So it can accommodate more users, more IoT devices, and less congestion. Then we have performance. So private 5G delivers high data rate, low latency, faster response, and the better user experience. So they can be used in like 4K videos, AI cameras, industrial robots, all these kind of things can be used. And then the most important point for private network is the latency. Low latency is very important in case of private networks. So the total latency can be around 30 to 60 milliseconds for many deployments, while application hosted at the edge can achieve much more latency. So suppose a robot receives command almost instantly because the application runs the network edge instead of distance cloud. Then we have reliability and guaranteed quality of service. So QoS means quality of service, and private 5G can prioritize important traffic even if the network is busy. For example, in a factory, robot control traffic gets the highest priority, but employees internet browsing can get the lower priority, right? Again, QoS stands for the quality of service. It is a feature of 5G that allows the network to prioritize different types of traffic based on its importance. So think of it like a highway. So suppose in a highway, ambulance can have highest priority. Then we may have bus, public bus, which has medium priority. And then we have private cars, which has least priority, or you can say that normal priority, right? So when roads are busy, ambulance will be given highest priority. And if there is no space, then buses and private cars will not be allowed to use, will not be allowed to use that roads or that highway. Same with the wireless networks as well. Suppose robots are using lots of traffic, then and there is no bandwidth left, then employees internet browsing may be stopped, but robot traffic will not be stopped because it has highest priority, right? So why we need QoS? Because not all applications have the same requirements. Without QoS, every application completes. So every application has a competition fully with the bandwidth. But with QoS, mission critical traffic always get the highest priority. Again, like example of factory, I have said that like robot commands highest priority, right? Then we have camera video. It may have high priority. Then we have employee internet, like employees browsing the internet, right? Then it has the lower priority. Right? So production continues without interruption because of QoS. So 5G uses something called 5QI for the priority. 5G QoS identifier. So each application gets different QoS profile. Like robot control may get ultra low latency profile, video may get high bandwidth profile, IoT sensors can get small bandwidth, internet get best effort, right? So network automatically manages these priorities. Then we have this second enabler, which is edge computing. So edge computing or multi-access edge computing. Nowadays, everyone is talking about edge computing. But what exactly is edge computing? The easiest ways to think about is ask a simple question. Here is my application. You know that traditionally most applications are in the cloud, right? That means whenever a device sends data, it has to travel all the way to a remote cloud data center for processing. And then response comes back, right? It has to complete all this path, right? So this works well for many applications, but it introduces extra delay, or you can say more latency. But we want less latency, right? So instead of processing everything in the distance cloud, we are moving applications closer to the users and the devices, and this is called the edge computing, multi-access edge computing. What is called? Multi-access edge computing, right? So the first place we can move the application is the mobile operators network edge. So this is called MEC. So here applications run inside the operator's edge network instead of distance cloud. And because the application is much closer to the user, latency is significantly reduced. But in addition to that, we can move the application even closer inside the enterprise itself. For example, if we have a factory, a stadium, a warehouse, we can install all the applications on a local edge server inside that facility. So now the data never has to leave the building. So response become even faster, right? So think of it like an ordering food, right? Suppose with the help of cloud computing, the restaurant is in another city, so delivery takes longer. But in case of multi-access computing, the restaurant is in your neighborhood, so delivery is much faster. In case of enterprise edge, the restaurant is inside your office building. Right? The closer the application, the faster the response. In the previous slide, we saw that applications are moving from central cloud closer to the user. So one important example is MEC, multi-access edge computing, right? So looking from left to right, user generate traffics like browsing, video, and many enterprise applications and connect to the 5G base station. This is our 5G base station. So instead of sending everything to this distance cloud or distant cloud, some traffic is processed on a MEC server located close to the network edge. This provides lower latency, faster response, reduced network traffic, and better security. Nowadays, everybody is talking about security. The more security we can achieve when everything is in the enterprise. But when MEC is near the actual traffic, it also improves the security, right? So the idea is bring applications and processing close to the users instead of sending everything to the cloud. So now let's see how MEC actually works inside the network. First of all, device connection. So we have different devices such as smartphones, cameras, IoT sensors, all these devices connected to the nearest base station. Right next to the base station, we have this MEC server. So this is where the applications and services are hosted. So instead of sending every request to the distant cloud, many applications are processed locally on MEC server. Then we have this cloud connectivity. So MEC server is still connected to the central cloud. If an application needs longer term storage or maybe AI model training or enterprise database, the data can still be sent to the cloud. So MEC doesn't replace the cloud. It works together with it. Then we have this core, right? 5G core or LTE core. The MEC platforms also connect to the mobile core network. The core continues to handle using many things like authentication. It may handle mobility, session management, policy controls. All these things can be controlled with the help of EPC, right? So this is all about MEC. Next important enabler is network slicing. So we have talked about MEC, which brings application closer to the users. But another powerful feature of 5G is network slicing. So network slicing allows one physical 5G networks to behave like multiple independent virtual networks. So again, what is slice? So slice is just a virtual or logical network on top of same physical 5G infrastructure. So think of creating a dedicated network without building a new physical network. So example, suppose consider an analogy like a highway. In highway, we have several dedicated lanes. Suppose emergency vehicles have own lane, buses have different lane, trucks have different lane, and regular cars have remaining lanes. But everyone uses the same highway. Each uses the same lights. Each uses the same infrastructure. But everyone has different specific purpose. So network slicing is exactly the same. And we can have different slices like best effort slices, industrial automation slices, drone slices, and MIoT slices. All this I have explained in my network slicing video. So please go to YouTube and please see the network slicing video in detail. And in that, I have covered this SST part and the SD part as well. So these are the important enablers of 5G we have already discussed, like latency, spectrum, virtualization, MEC, network slicing, and all these things we have already discussed. Now the question comes when to use what technology. So private LTE, choose private LTE when you need a reliable private wireless network. And it is best for manufacturing plants, mining sites, stadium, etc. Then we have private 5G. Use private 5G when you need very high speed, ultra low latency, high security and reliability, and you plan to connect thousands of devices. And it can be used for smart factories, right? AR/VR applications, remote machine controls, mission critical applications, all these things, right? So a modern automated plant using robots, AI cameras, autonomous vehicles can be good example of private 5G. And Wi-Fi is more suitable for corporate office or home applications. And IoT that requires large number of sensors with very small power. So let's have one quick quiz. So first question is CBRS. So what's the full form of CBRS? Yes. So right answer is Citizen Broadband Radio Service. Second is private network brings benefit to organization because first of all, they offer high security and encryption. They reduce interference with Wi-Fi and cellular users. Sometimes they do, sometimes they don't do. So we can't use this. We can't use this. They need license, right? So they offer controlled and guaranteed coverage, and they allow organization to have better access control. Thanks for the right answer. Then what are the two types of CBSD? If you remember, we have discussed category A and the category B CBSDs. And is which band CBRS has been allocated 150 megahertz of spectrum? The right answer is 3.5 to 3.7 gigahertz. Right? So friends, this is all from my side. Let's recall. So we have already discussed 5G building blocks. Then we have discussed all these things that 5G is not 4G plus. It is lot more as compared to LTE, right? Or any previous technologies. All these things we have already discussed, right? 5G performance requirements, private network, all these things we have. Also, in this session, we have discussed technology overview. Then we have discussed MEC, examples of MEC, how to do CBRS frequency management, what are the CBSD devices, and what are the CBSD requirements, end users EUD, CBRS antennas, and the private antennas enablers. All these things we have discussed in the today's session. So again, friends, as I said earlier that to become successful, you need passion to grow, skills, experience, and target. So keep training, keep learning until you get it right. Again, friends, this is me. My name is Gaurav Goyal. For more information about me, please go to my LinkedIn profile and follow me on LinkedIn for the next webinars or the new post related to private networking, NTN, AI, and all these things. All right, friends, that brings ends to our today's session. Thank you everyone for being here. I truly appreciate your interest and participation throughout the webinar. I hope you learned something new that can apply in your network. So keep exploring, keep improving, and keep moving forward. Take care of yourself, your families, and stay positive. Again, thank you so much, everyone, and have a great day. Thank you.